Hey guys, Mrs. Dan's here. So we're on lesson 2 of our recursive sequence unit. And today it's like we're doing a reverse of what we did yesterday. Yesterday we were given a recursive formula and we were able to list the terms. Today you're going to have the terms and you have to be able to make up the formula. So a huge reminder is that a recursive formula has two parts, right? The first part tells you what the first term is, and the second part tells you what you're doing. And remember, it's the notation that tends to get a little tricky. So just take a look at what I wrote for the second part. On the left side of the equal sign, I have an a sub n. And on the right side, I have an a sub n minus 1. Remember, in order to find a term, you have to know what comes before it. So this is what comes before the a sub n. A sub n minus 1 definitely comes before a sub n. There's dot dot dots both in front and behind because maybe I'm multiplying by something, maybe I'm adding something. I'm definitely doing something to this term. You should check your homework answers from yesterday. I want you to know how to do yesterday's stuff before you do today's stuff. And there's a do now for you to do. And we'll go over the do now, do the development. The classwork I crossed off in pairs. If we were in school, you'd do it in pairs. But I'll do it for you or with you. And still, you should be able to tell me what a recursive formula is and what it is that we see in a recursive formula. So recursive formula, remember, is something that builds upon something you already know. Recursive formula comes in two parts, and that's what we see. We see two parts, and that's a huge hint that it's recursive. And in one of the parts, you have this strange notation on both the right and the left-hand side of the equal sign. That's like a hint that it's recursive. And then your homework is provided as well. This is just reminders of arithmetic and geometric sequences. You can read it on your own, but in general, you continuously add on a number for it to be called arithmetic, and that's called the common difference, and we use a D when we're doing our explicit formulas at least. And a geometric sequence, you multiply by the same number again and again, and that's called the common ratio. So this do now really is review of what we did yesterday. First, they're asking us to determine if it's arithmetic or geometric, and then they want the first four terms. So I see two parts. I definitely know it's recursive, and they're telling me the first term, and I can see what they want me to do. They want me to subtract 5. That means this is arithmetic. Right? When you add or subtract the same number each time, it's an arithmetic sequence. And then we'll go back and write the terms in a second. On number 2, there's two parts to it. Therefore, that's why this is a recursive formula. But I could see right here, they want me to multiply by a half. Oh yeah, when you multiply by the same number again and again and again, it's called geometric. And then in number 3, they give me the first term. They're telling me what to do. They're telling me I'm adding on n. Now n continuously changes, therefore it's not arithmetic. Right? Arithmetic, you have to add on the same number. Also, we're multiplying by something, so this is one that's a neither. Let's go back and write the terms. You never ever mess up the first term. It's given to you. So you better write that down immediately. Never leave a question blank, at least have the first term written down. And they want a total of 4 terms, so I have to find 3 more. And this tells me what to do. I have to subtract 5 each time. So I have a 1, a -4, and a -9. Arithmetic sequences, while given a recursive formula, they're easy. You can do this. I know you can. Geometric, definitely know the first term. Write it down immediately. You have to find 3 more terms. This tells me what to do each time. I have to multiply by a half each time. 4 times a half is 2. Half of that is 1. Half of that is a half. Definitely another thing that you could absolutely do. You could easily do arithmetic and geometric sequences if they're defined recursively. Never panic over that. This is the only one that makes you think a little bit. So I definitely know the first term, so I'm going to write that down. This way maybe I could get some kind of credit. And then what I see is that I have to multiply what I know by 2, and then I have to add on n. So the tricky part is what the heck is at n? I can easily multiply by 2, right? 10 times 2 is 20. But then what am I adding on? So in order to figure out what to add on, I actually have to keep track of my terms. So this is the first term, this is the second term, this is the third term, and this is the fourth term. So that means this is when n is 1, this is when n is 2, this is when n is 3, and this is when n is 4. Something I have to notice in this second part is I'm adding on n. This is what I'm given. I'm given 10. I'm given a sub n minus 1. I don't want to add on the term that 10, the number that 10 is in the place of. I want to add on what comes after it. I want to add on this 2, right? If this is an n minus 1, n comes after it. If this is in the n minus 1 place, this is the one I'm adding on. So to this 20, I'm going to add on a 2, and I have a 22. So let's do the next one. So this 22 has to first be multiplied by 2, so I have a 44. Remember, I added on the one after. Maybe drawing this arrow is helpful because now I'm going to add on a 3. Now I take the 47 and I multiply it by 2. That's a 94. I'm going to draw this arrow. I'm adding on 4. So I get 98. So the hardest part is that very initial one right here of me deciding to add on 2. That's what I find to be the hardest. And then everything else follows the same pattern. And remember, the reason why I added on the 2 was because I was given an n minus 1, but I wanted to add on the n. I needed to add on what comes after n minus 1. After n minus 1 is n. That comes after. That's the n I'm using. And then each time, it's always the one that comes after. So if anything's going to be tricky, it's going to be this. Just because these types of questions are tricky doesn't mean you can't go and do these easy ones. So you always just do the best you can. If you're adding on the wrong number, you're going to get partial credit if you're following some kind of recursive rule. So no panicking. So there are some steps you can follow to make sure you're writing your recursive formula correctly. First, you're going to decide if it's arithmetic or geometric, right? That's important to know. If it's arithmetic, you want to write down what the common difference is. And then to write your recursive formula, first tell me the first term, and then tell me what you're adding on. And then if it's geometric, you need to write down what the common ratio is. And again, write the first term, and then write down a formula that tells me what to multiply by. So it's easier to actually do the problems instead of looking at the words. So if we take a look here, you notice what I notice, that we're adding on 4 each time. So that means this is arithmetic. And the common difference is 4. To write a recursive formula, you have to first state what the first term is, right? We need a starting point. So I'm going to say that a sub 1 is -2. You always give the first term. And then I want to find a sub n. That a sub n comes from what I know, which must be an a sub n minus 1. What am I doing to that a sub n minus 1? Oh, I'm adding on 4. Done. This is your recursive formula. The 2 parts put together. That's all you're doing. Let's take a look at number 2. What's happening each time? Do you agree that you're subtracting 2 over 2? Which really means you're subtracting a -1. So this is arithmetic. You're not subtracting a negative 1. Sorry, you're adding a negative 1 or you're subtracting 1. Just got to say that right. So the common difference is a negative 1 because I keep on adding on negative 1. If I write the recursive formula, the first part of it's easy. A sub 1 equals negative a half. The second part always start off the way that my objective was written. I would always write the a sub n, and I would write the a sub n minus 1, and then decide what to do to it. So I have a sub n, and this is an a sub n minus 1, and this is what I'm doing each time. So this, I subtract 1 from it. I didn't have to put that in parentheses. I just wanted to point out that that's the thing that I'm subtracting 1 from. You're allowed to put parentheses, but it's not necessary. On number 3, what's happening? We're definitely not adding on the same number. We're multiplying by something. And if you can't figure out what you're multiplying by, we did this in the past, but I'm just going to remind you, you could go in reverse and divide. If I do 3 divided by 2, it's going to tell me my common ratio. 3 divided by 2, you should all know, is 1.5. And test that out. If I do 2 times 1.5, yes, it worked. And then times again by 1.5. Yes, it worked. Times again by 1.5. And it worked. So I'm confident that this is geometric and that the common ratio is 1.5. So now to write the recursive formula, state the first term, have an a sub n on one side, and an a sub n minus 1 on the other. Since I'm multiplying by something, I usually put that in front. I'm multiplying by 1.5. I could leave it like this, or if you like parentheses around it, that's fine also. You could even put parentheses around both of them if it looks better to you. It is multiplication. Whatever you know gets multiplied by 1.5. So here we are adding the same number, right? We're adding 0.5. Test it just in case you're unsure. You know, a half is 0.5, so 0.5 plus 0.5 is 1, and if I add on 0.5 again, I get 1.5, which is the same thing as 3 over 2. If I add on 0.5 again, I get 2. So definitely this is arithmetic, and the common difference is a 0.5. My first term is a half, and I have a sub n equals a sub n minus 1, and I have to add on a 0.5. Number 5 looks like I'm multiplying by a number. I'm multiplying by 1/3. So it's geometric. The common ratio is 1/3. My first term is 1, and I'm finding a sub n. I'm using a sub n minus 1 to help me. To this number, I'm multiplying by 1/3. This next one looks like I'm multiplying by 0.1. Again, you could always test it if you're not sure. 10 times 0.1 is 1, times by 0.1 is 0.1, times by 0.1, 0.01, so I'm definitely right. It's geometric. The common ratio is 0.1. my first term is 10, a sub n will be 0.1 times a sub n minus 1. And then we could do it with word problems. So Edgar, thank goodness, is getting better at math. On his first quiz, he scored 57. Notice I said first quiz, so that's the first term, right? Then he scores 61 and 65 on his next two quizzes. If his scores continue to increase at the same rate, so that's kind of a hint that we must be adding on the same number. Do you notice we can add on 4? So this is arithmetic. The common difference is 4. So let me finish. If his scores continue to increase at the same rate, what will be his score in a fifth quiz? 1, 2, 3, 4, 5. So I put dashes so I know how far I'd have to go. I'm adding on 4 each time. I hope he continues to increase so he could at least get into those 70s soon. And now it says write a recursive formula. So a sub 1 equals 57, a sub n equals a sub n minus 1 plus 4. Number 8, suppose you drop a tennis ball from a height of 15 feet. After the ball hits the floor, it rebounds to 85% of its previous height. How high will the ball rebound after its third bounce? So the tricky part here is that the starting height of 15 feet is not the first term, it's like the 0 term, because it hasn't bounced yet. Right, because they're saying that after the ball hits the floor, it rebounds to 85% of its previous height. So if this is where it starts, here's 1 bounce and it comes up. Here's 2 bounce and it comes up. And here's 3 bounce and it comes up. So we have to be really careful. This is the 0 term. The other thing that we have to be careful about is we want to change this 85% to a decimal so that we can multiply, right? So that it really does look exponential. Remember, geometric sequences look exponential. So the common ratio is really 0.85, right? If it's 85%, we change it to a decimal. How high will the ball rebound after its third bounce? So this will be after the first bounce, this will be after the second bounce, and this will be after the third bounce. So I want to do 15 times 0.85. 12.75. Then I want to multiply that by 0.85. $10.8375. Then I want to multiply that by 0.85. 9.21875. Didn't tell me to round anywhere. Well, yes it does. It says round to nearest tenth. So on the third bounce, after the third bounce, it will be at a height of 9.21875. 2 feet. So I was able to answer the question. I didn't write the recursive formula though. The first term is 12.75, and a sub n is gotten by doing 0.85 times a sub n minus 1. Number 9, write a recursive formula for the number of squares in a sequence. So let's count them. There's 1, 3, 6. Now this one is a neither. I'm definitely not adding on the same number. Right here, I add on 2, and here I add on 3. Am I multiplying by the same number? If I multiplied to get from 1 to 3, I'd have to multiply by 3. But if I multiply to get from 3 to 6, I'm now multiplying by 2. So it's a neither. Let's figure this one out. I know the first term is 1. I know I need an a sub n, and I need an a sub n minus 1. And I have to do something to this a sub n minus 1. Do you notice that I'm adding on 2, adding on 3, so this is going to be an add on 4. So it seems like I keep on adding on 1 more. This is reminding me of our do now. I added on 2, then I added on 3, then I added on 4. Keep on adding on 1 more. So this is something to do with an add on n. Now this is where you have to be careful. This is when n is 1, this is when n is 2, and this is when n is 3. So to get my new thing, if I start with 1 and I want this to be a 3, I had to add on that 2. If I go from 3 to 6, I have to add on that 3. Notice where my arrow is. I'm adding on the n that comes after. So this is the n before. To this, I'm adding on the n that comes after it. And again, this one is just the tricky kinds. So I know you guys can do this. Arithmetic and geometric, remember, are the simple ones. So a lot of these are arithmetic and geometric. I'm not torturing you with lots of the add-on n's. So be careful also when you get to the wording of, is it a 0 term or a first term? If I were to remind you about number 7, the reason why this was a first term was because it said his first quiz score, right? And the reason why this was a 0 term is because we're only determining the height after it bounces, and this is a starting height. It didn't bounce yet. So just be careful of some wording. Send me any questions that you have, and I hope to hear from you soon. See you. Bye.